To the questions that I'm about to ask you. The goal is to go 5 for 5. For every question you miss, you lose a limb. If you miss all 5, you lose all 4 limbs and your head.
Hey, I mean, I don't have to come to school at that point, so.
Okay, question number 1.
No absolute win.
Passive transport moves with or against the concentration gradient. With or against? Don't look at other people, just tell me what you think you know. If you want to get out your notes from Monday, you can't do that. You won't need those later anyway. Good. Everybody's that I've seen so far is right.
Yay!
Good? Don't look at other people's. Yes, you did. I saw you look at hers and then you wrote it. Okay, very good. With the concentration gradient. Remember, passive means that you just go with the flow, right? The flow is with the concentration gradient. That means what to what? High to low. Very good. Second question.
Can we erase this?
Yes. Second question. Active transport moves with or against the concentration gradient. Good. What the heck does that say? Excellent. Good. Against the concentration gradient. Active requires what? Energy. Because you need energy to go against the flow. Right? Third question. Diffusion is a type of passive or active transport. Passive, good. Shoot, I just gave the answer. What am I doing? Good, passive. Excellent. Good.
When you literally put active when he said that.
Oh boy, what a train wreck. Is it Friday yet? Okay, so diffusion is a type of passive transport. Give me an example of diffusion. The perfume. Perfect. What about in our cells? What is something that diffuses?
Oxygen?
Oxygen diffuses. Very good. Okay, very good.
Good, right. Let's go.
Remember, diffusion is passive. Much like the perfume that I sprayed over here, I did not have to put any energy into making it move throughout the room. It did it itself. It just went with the flow. That is passive. Very good. Question number 4. Passive moves from what to what concentration?
Don't give out the answer.
Good.
Don't give out the answer.
Excellent.
Oh, I thought I was
Terrific job. Wonderful job. You're a rock star. You have nothing. I'm kidding. You're great. You're awesome. Excellent.
Nothing.
Okay. Oh, shoot. The answer is
Oh, it's too low.
high to low. Very good. Excellent. High to low. The hardest question. Active transport goes from. Kidding. This is not the hardest question. That comes next. Good. Excellent. You all are geniuses. Straight up G's. You are the OGs.
What's that our 5 question?
The original geniuses.
That's only 4.
Good.
Don,
Okay.
did you say that to every class?
I didn't say it to the second one, so I guess they weren't geniuses. I don't know. Very good. So active goes low to high because you need energy to move against the concentration gradient, right?
Yes.
Okay, hardest question. You have
It's only been 5 questions.
what? What?
You went
What?
like that.
Last question. Hardest question. I'm going to give you 3 minutes to either answer this by yourself or with people. From what you have learned about diffusion of CO2 and oxygen, explain why you breathe harder when you exercise. Once you explain that, I want you to draw that example out using a cell and those molecules like we were doing on Monday. Why do you breathe harder when you exercise? 3 minutes, go. By yourself or with people.
Brandon, I've got some help for you. I hope you know this answer. Because you expended more energy.
Oh, that's what I said. Wait, we just draw it. You can't write it.
I know.
How do we draw it out?
The first thing to think about would be, why do we need
Mr.
oxygen?
Tom, can you read this?
Why is oxygen important?
So we can draw. Can you read this? We're
Bigger.
in the way.
Think bigger.
Can you read that?
Nope.
So our muscles can work.
Okay,
Do
Mr.
you have
Dom.
to draw it or can you write?
Bigger.
No,
You have to
he
draw
said-
it?
He said draw.
No, you don't.
I want you to draw the example.
Oh my god.
Explain and here, let me see your thing. Sure, let me see your thing.
Nope.
He said draw the example.
When exercising,
Think about it. Why do we need oxygen? What does oxygen do for our cells?
You're making more
No,
energy.
it replenishes them.
No.
Gives them energy.
So you have enough
Maybe.
energy to run.
Yeah, it gives them energy.
So why is that important in relation to this?
Oh, so I know it.
You're on the right track.
You're giving out more oxygen, so you need to breathe in more. And you're wasting
Maybe.
energy. Because you're losing
Okay, I
oxygen.
don't
I'm
spend
right.
my entire
I don't know how
life
to
savings
draw
on
it.
biology.
I do.
I'm guessing you draw this.
It did work.
You did.
I drew a circle.
That's,
Wow.
you know what, but how that was, that's pretty tough work.
I know.
1 minute.
Alright, I don't know what to draw.
Is that, put some oxygen in there to be
I did put O2. There, there's another O2.
Mr.
But
Dom,
I drew
Mr.
the
Dom, come here. I've got this. Yeah. Because you're moving, you're losing energy.
Okay.
You have to use more energy out. Because you're doing that, your body's
So,
trying to
I might
trying to
raise it.
bring in more oxygen so that you have enough energy to be able to keep moving.
Perfect. Nailed it. Okay, we got it? I'm going to cut you 30 seconds short.
Aw, that's not
there's
fair.
our diagram. There's our.
I'm kidding. 29 seconds short. Okay, so somebody explain to me why. Why do you breathe harder when you exercise? Aiden.
So your cells use oxygen and they make energy from it and stuff. Well,
Okay.
make it. Yeah.
Copied us.
Let him talk.
And then like when it doesn't have oxygen, it can't make energy. So it pumps harder to make more oxygen.
Good. What do you have to add?
It's basically created by the O2 and CO2. So energy, basically.
Good. Sarah?
You're breathing out all the oxygen and your oxygen is
No.
Breathe
So it's
out
all
CO2.
about
Hold on.
energy. Remember, the reason why we need oxygen is so that we can make energy, right? What two molecules are necessary for making energy? Oxygen and
CO2.
glucose.
Or
Okay?
glucose, yeah.
So we take in energy so that we take in oxygen so that we can make energy. So when you're exercising, why do you need more energy?
Because you're using more energy.
Because you're using more energy, right? So the reason why your heart rate increases and the reason why you start breathing harder is so that, one, you breathe in more oxygen, your heart rate's increasing so that the oxygen can get to your cells quicker so that you can make more energy, right? So let's think about what this would look like. In my cell, am I going to have a lot of oxygen or a lot of CO2? Ladies, cut it out. A lot of CO2. Why, Rory?
Because you don't have enough oxygen. Well, it's because it's constantly making CO2 with the energy.
Right, because when you make energy, what do you produce? CO2. As you breathe in harder, your bloodstream is going to be loaded with what? Oxygen. Which is going to mean that the oxygen is going to move where?
Into the cell.
Into the cell. And the CO2 is going to move where?
Out into the bloodstream.
Out into the bloodstream so that you can do what with it? Breathe it out. Right? That makes sense? Maybe? Are you good?
Yeah.
Cameron, you still stupid confused?
No, I'm getting.
Okay, you get that?
Call it stupid.
No, I said stupid confused. Like, really confused. Rory, are you feeling stupid? Good answer. Okay, everybody good there? Okay, moving on. Do me a favor, cap your markers.
But why?
Because I don't want you writing on my boards with them because that wastes my markers like that. Captain markers. Captain markers.
No.
If you don't already have out your notebooks, I would have those out.
Oh, yes, because Mr. Dom. Oh, yes. That's not wasting. Turn
What?
around. Turn around. That's my
Yeah, that's you.
No, only one thing is moving.
Okay, so before we begin today, we're going to watch this really quick video. This video is another scenario that I'm going to introduce to you about death. And then your job over the next couple days is to explain why this individual died. Okay, so here's the setting. All right, so this lady, her name is Jennifer Strange. She entered a radio contest right around Christmas time. This is way back in the day, right when the Nintendo Wii came out. All right. So she entered this radio contest, and the contest was this. It was called Wii for a Wii. She had to drink as much water as she could without going to the bathroom, and the person who drank the most water without going to the bathroom won the Wii. One problem. She won, but she also died. So let's watch this just
Can't
for
you
her.
like drown from drinking?
No, it was overhydration.
There are more ways to die than the human mind can imagine. Some are sudden and shocking. Others are slow and methodical. But every death, no matter how strange, can be explained. Even the most curious and unusual.
Juggle. It's 107.9 The End, today's hit music, where we're holding our Wii for a Wii.
It was a competition with some unusual rules. Each contestant was given an 8-ounce bottle of water and 2 minutes to drink it all.
Ladies and gentlemen, start your bladders.
That guy's really sucking it back.
Oh my God, I've never seen anybody drink like that before in my life. He's done that before, I think.
2 minutes later, they're told to finish another. Another 2 minutes, and another 8-ounce bottle. And on it went. To spice things up, contestants who went to the bathroom were eliminated. Whoever went the longest without peeing would win the Wii. No one was aware this competition could have dire consequences. Dr. Pete Lemon, an expert on water intoxication, explains how simply drinking water can be deadly.
The composition of the water that you're drinking is more dilute in electrolytes than the fluid in your body. And so what happens is the rapid intake of water causes a rapid dilution of the blood.
Electrolytes circulate in our bodies. The most common, sodium. Consuming too much water can dilute the electrolyte levels in our blood. To rebalance these levels, cells absorb the excess water, making them swell, which can have lethal consequences.
Get these fluid movements into the cells and they essentially expand and explode.
Having consumed over 8 liters of water in less than 2 hours, Brant is experiencing lethargy, fatigue, nausea, and a severe headache.
The brain, as it swells, begins to push the contents of the brain down through the path of least resistance, through the hole in the bottom of your skull called the foramen magnum. A portion of the brain jams down into the foramen magnum, squeezing a part of your brainstem called the medulla oblongata. This is the part of your brain that carries all of your vital functions, that tells you when to breathe, tells your heart when to beat. And so when it is crushed by the weight of this pressure, you have something called tonsillar herniation. And when that happens, you die.
Okay, so in a nutshell, homegirl Jennifer drank a whole bunch of water and inevitably died because her brain crushed itself to death. This is real. This is real. So on Thursday, no, what the heck is Thursday already? So on Monday, we're going to kind of look at that situation, and what you're going to need to do is determine how the heck this happened in relation to what we talk about today. Okay? And what we're going to talk about today is osmosis, which if you are the ideal perfect student, you already have a general understanding of this because you did the assignment that you were supposed to do on Tuesday. So hopefully that was all of you. Okay, osmosis.
Yeah.
Plain and simply, osmosis is exactly like diffusion. The only difference is it only involves what? Water. Okay? Do you know what diffusion is? What is diffusion?
Spreading.
What? It's the movement of things from what to what?
High to low.
High to low. Okay, that was the perfume, that's the oxygen, the CO2, every example we've used so far, that's diffusion, right? Osmosis is just like that, except it's only focused on the movement of water. Okay, so that's what we're going to look at over the next couple of days, is osmosis. Okay? Before we get too deep into osmosis, we got to take a little road trip back to middle school. Okay? How many of y'all remember anything about these two words? A little bit, maybe? What's a mixture? Someone tell me that.
Two different things combined.
Two different things combined. What's an example? What? Sugar, water?
Or like flour and water. Flour
Yeah, that's what I
and
meant.
eggs, or-
Okay. What's a solution then?
Like to fix it?
Nope.
Solution? Probably like isolation.
I'm only thinking about math.
Only thinking about math.
Yeah.
Okay, I'm going to give you an example. I got some water in a cup. I got some sand. If I put them together, what does this make?
Sand water.
It's a mixture.
Sand water.
What's
This is a mixture. I have two substances mixed together, but what can you notice about this?
It doesn't actually like
The sand doesn't what?
dissolve.
Dissolve. Okay? The sand and the water are clearly both present in this cup, right? That is an example of a mixture. Now, if I take water, again, and then I take salt, put that into water and mix it up, how does this look different than that? The salt dissolves. Okay? So the difference between a mixture and solution is that a mixture is two or more substances combined where you can still see the multiple substances. Solutions, something is dissolving into something else so that it just looks like one thing. Does that make sense? Okay? Now, I'm going to take this solution and I'm going to add some oil to it. What do you think this is? That's a mixture and a solution, right? The solution is the salt water. The mixture is the salt water and oil, right? Does that make sense? Everybody clear on that? Okay, so here's why we need to understand that. When we talk about osmosis, we have to understand solutions, okay? Because solutions generally are always going to involve water, okay, for the most part, okay? And so when we look at a solution, there are two parts. There are two parts that make up that solution. These two words are really important for you to know. You have the solvent and the solute. Okay? So keep this really, really simple. The solvent is the major component of a solution. It's the dissolver. It's the thing that is doing the dissolving. Okay? So in our example of salt water, what is the major component that does the dissolving? The water. Okay? Solvent. Every example that we look at in this class, water is always going to be the solvent. Okay? Cheat code. Now you know. Okay? Water will always be the solvent. Water is considered the universal solvent because almost everything dissolves into it. Okay? The solute, on the other hand, is the minor component of a solution. This is the thing that is being dissolved. What got dissolved?
Salt.
Salt. Very good. So on your whiteboards, see how good you are. Tell me what the solute and solvent is for each of those three examples. Did I go too fast? Let me go back for a second.
Oh, okay.
Keep it simple. Okay? Don't feel like you have to write every word always. Okay, if you can literally know that the solvent is water and the solute is salt, and you know what that means, all you need to put is salt and water. Keep it simple, what works for you.
Can you go back to that other side?
Other side.
You just show us to like copy down all the things.
I will in just a second. I was letting a couple people finish this real quick. Okay, so 4 examples. Tell me what the solutes and the solvents are. You can do this together, by yourself, whatever you prefer.
We already did the first one though.
Yes, you did.
Okay, so you only have 3 too, or 3.
Kind of gave you the answer to most of this by telling you about the solvents. So I want to know what the solvent is for each of those. Not whether it's a solvent.
Well, salt water.
Perfect.
Salt water is just
All right, what you got?
coffee
Alright,
dissolves.
I
Think about it.
I think I got them mixed up.
So
some coffee.
soda would burn it.
Mr. Dawn.
So I think the only solvent is
Solvent is water.
Close. Okay, so here we go. You got one thing wrong.
Wait, Mr. Dawn, come here.
All right, so salt water. Okay, we already did that example. It's right there. The salt is the solute. The water is the solvent. Number 2, coffee. What is the solvent, Braden?
Coffee grounds.
The solute is the coffee grounds. What is the solvent?
Water.
Water. Okay. Elise, what about tea?
A tea packet is solute.
Okay, the tea leaves are the solute. What's the solvent?
Water.
Water. Okay. What if you put like sugar in your tea?
Yeah.
That would be a solute as well, right? There can be multiple solutes. Okay, sweet tea. Yeah, exactly.
Sweet tea is my favorite.
Yeah, me too.
Okay, soda. What is the solvent, Rory? Water. And the solute is? Could be syrup, could be sugar, could be food coloring, could be artificial flavoring, it could be anything that's in soda, right? There's a whole bunch of junk in soda.
It's so good.
Okay?
So
So good. Solvent's water. Solvent's water in every single one. Well, that, but I see what you were saying with like sweet tea. I was thinking like green tea, but yeah, I'm with you. You got it. You nailed it.
I just picked out these.
Green tea's gross.
Okay. Everybody good with solute solvents?
Yes.
Okay, lovely. So that's going to bring us to osmosis. Okay? So osmosis is the movement of water. Okay? This I would.
What if we already have it?
No. So if you're good with it, you're good with it. Only if you need to. Okay? So osmosis, there are 3 solutions or 3 examples that you will find your cells in that will determine how water moves in and out of them. Okay? We're going to talk about those 3 situations, those 3 solutions today. Okay? Again, just to recap, osmosis is the diffusion of water across the membrane. Okay? And that water will always move with the concentration gradient, high to low. Okay? One thing I want to address before we jump into that is this idea of concentration. Okay? So, for the examples, at least for the examples that I'm going to do right now, I'm going to assume that there are 3 water molecules inside and outside of my cell. Okay? Now, I'm going to use triangles to represent salt in these examples. Okay? So, I'm going to put 2 triangles outside, 4 triangles inside. Is the amount of water in and out the same? Yes. But where is the concentration greater of water? What? No.
Oh. No.
Where is the
outside.
concentration of water greater?
Outside.
Outside. Okay? So when we talk about concentration, think of it as like percentages. Okay? Because you're considering what is the concentration of water compared to everything else. Right? So outside the cell, I have, what, 3, we'll say 3, what do I got, 5 things there? 3/5 water. Inside the cell, I got what? 3/7. Okay? So where is the concentration greater? Out here. Does that make sense? So it's not always based on the amount of the molecules, it's based on the percentage of what it exists in. Okay? If that makes no sense to you, it will here in a bit, hopefully. Okay? Actually, let me just make this simpler. Example. Let's go. Okay, so, shoot, let's not do that. Let's not do that. We'll do another example here in this second. Okay, so let's look at this first situation that we got. Okay, so with osmosis, the first solution or type of situation your cell can be put in is what we call hypotonic. A hypotonic solution. And these are important for you to know. Hypotonic solutions is where water is transported into the cell, causing the cell to swell. Okay, here's how I remember this. 2 ways. Hypo, the O is for obese, because the cell is getting fat, because it's filling up with water. Okay? Or hippo, hippos are fat. Again, the cell is getting big. The cell is filling up with water. Okay? So here's why this happens. Okay? This says the solute concentration, so in all the examples we're going to use for our cells, the solute's going to be salt, the solvent's going to be what? Water. Okay? So this is saying the solute concentration inside is higher than outside. Okay? So I'm going to go actually make this easier. For H2O, I'm going to draw circles. Yeah, like I did right there. Duh. Okay, so solute is going to be triangles, which is salt. Okay? So, look at this. Where is the water concentration greatest? Outside. Okay? So where is the water going to move?
Inside.
It's going to move in because it always moves from what to what? High to low. So the water concentration is higher out here, lower in here, which causes the water to move in. That is a hypotonic solution. If water is moving in the cells, it's getting obese. It's expanding. It's swelling up. That's hypotonic. Okay? In all of these examples, the only thing we're worried about moving is water. We're not talking about the salt. Okay? The water is what's moving in and out of the cell, not the salt. Okay? Does that make sense? Okay, so let's look at the next example. Okay? If it's not hypo, another thing that it can be is hyper. Hypertonic. E for exit, or if you're hyper, you have a whole lot of energy, you probably exercise a lot, and you get skinny. Okay? So water is transported out of the cell, causing the cell to shrink, to shrivel. So what has to happen for that to be the case? How you doing?
Still having flies.
Oh, all over this wall.
I got a copy of the email this morning.
Yeah, so it's my room and these, all the rooms on this side.
All of them on this side?
Yeah, but I mean, it's like, now it's flies, this
Oh, yeah, there's flies
summer and
in
early
there.
fall.
They said
is
earlier
flies.
this summer you had water.
Yeah, and I mean, it's a ton, so,
Hmm?
I don't know where.
So when they get on the roof and try to find her, just go buy about 30 fly swatters to get rid of it.
I saw
Whatever.
Either way.
Okay. I'll get up and see if I can get to the bottom.
Okay, thank you.
Remember when you grabbed the tissue and the tissue and
Oh, it blew up? Yeah, that was funny. Okay, so what would have to be the case in our cell and outside of our cell for hypertonic to occur? There would have to be more solute outside of the cell. So water is greater where? Inside, which means water is going to move out. Good. Does that make sense? Water is always going to move high to low. Okay? So hyper, it exits the cell, loses water, therefore it shrivels. Okay? And that brings us to our last solution, our last example or type of situation that our cells can be in, and that is isotonic. Okay? Isotonic is where the amount of water transported into the cell is equal to the amount that is leaving the cell. So the way that looks is you have water coming in and out in equal amounts. The cell is not shriveling and it's not expanding. This is ideally where all your cells want to be. So what does the water and salt look like here? They're equal. Okay? That's exactly where our cells want to live, because it's balanced and equal.
Well, what's the fun of that?
That's exactly right. There is no fun in that. Okay, so I want to throw a couple examples at you. Teenage life examples. Okay? So Rory goes home today, sits his butt on the couch. First off, before I move on, when I say this stuff's outside the cell, where is it really at? In the bloodstream. Okay. So Rory goes home, sits his butt on the couch. Actually, not Rory. This is more of a Braden Gantz example. Braden Gantz goes home, sits his butt on the couch, grabs a whole bag of potato chips, and eats it all. What is going to be really high in his bloodstream? Salt. His bloodstream is going to be loaded with salt. Like it is all the time, right? So, what is going to happen to the water in Gantz's cells?
They're going to leave.
The water is going to leave to try to balance out the bloodstream, which is going to cause his cells to shrivel, right? Think about it. You eat a lot of salt, you get what? What's the word? What? You get thirsty. You get dehydrated, right?
Because your cells are thirsty.
Because your cells are thirsty. Because all the water is being pulled out of your cells into your bloodstream.
That's crazy.
Right? Okay? Does that make sense? Okay, so let's look at another example. So you go home, you go to practice, you're wore out, you get home and you're like, man, I'm thirsty. So you grab a gallon of water and you chug it. Okay? So Gantz chugs all the water. What's going to happen in your bloodstream? What's it going to be full of?
Water.
Water. So now you got a whole bunch of water in your bloodstream. What's going to happen? Water's going to move in and your cells are going to get really big.
And then go.
Okay? Do what? So think about, if you just kept drinking, what's going to keep happening to your cells? They're going to keep getting bigger and bigger and bigger and bigger until what?
Pop. Until you die.
Pop.
And then you die.
What example have we looked at that would be this?
So one chick.
Homegirl that just died by drinking too much water. Right?
Is this right, Connors? What? What is it?
Okay?
Have you not listened?
He slept. After the first 5 questions, he was done.
No.
Okay, does that make sense?
Verse 7.
Okay, so then let's think about this example. Let's say you go home, you've ate a pretty good, healthy, even diet, you've drank a good amount of water today. You haven't had too much of anything. And you're just balanced on both sides. What would that be?
Isotonic.
Isotonic. It's just going to chill. This is where you just want to be. It's just going to move back and forth equally. Does that make sense? Okay, another, let's see. What is a case where maybe you would like use salt water? Gargling salt water.
Yeah.
Why do you gargle salt water?
Kill bacteria. To heal something.
What specifically?
Your throat.
Your throat, right? If your throat's
Dry.
sore, right? So generally, you would gargle salt water because your throat is sore because it's inflamed, right? Okay, it's inflamed. So why do you gargle salt water if your throat is inflamed?
To get your cells down.
To drain the something.
What is all that salt going to pull out of your cells?
Water.
Water, which is going to cause your cells to
Shrink.
right? So they're not going to swell as much.
What?
Does that make sense?
It's
Crazy.
Well, why does salt help? Like, I
salt's
have to
a
soak
miracle
my toe and salt after the surgery.
Because salt is pulling water out of your cells, reducing that inflammation. It's reducing the swelling.
Oh, yeah.
Salt works wonders.
Okay, so here we go. Same example. So Gans eats potato chips. Is this hypo or hyper?
And goldfish, and
hypo.
animal crackers,
Hypo.
and
Follow me here.
No, hyper.
Hyper,
Yeah.
because it's exiting, water is exiting the
Yeah.
cell, right?
Yeah.
Okay. You gargle salt water.
That's hyper.
Hyper or hypo?
Hypo. Hyper.
It's still hyper.
Yeah.
It's pulling water out. Okay? You drink a crap ton of water.
Hypo.
That's hypo.
That's going in.
Because it's going to be moving in. Good. Excellent. Everybody good with this?
Yes.
Okay, lovely. How much time we got?
Like 2 seconds.
2 minutes.
Like for real, for real?
Yeah, we have like very little time.
Okay, guess what? Guess what?
What?
If you can promise me that everybody completes your assignment tomorrow, I'm not going to make you do this that everybody else had to do.
I can promise you that.
Wait.
You already did it?
Yeah, I already did it.
You already did what?
Wait, the
Y'all supposed
introduction or the one that you just posted?
The one I just posted.
Okay,
Oh.
never mind.
This is different. Everybody else had to do this in class. You guys don't have time. If you want this is just more practice.
No, I'm good.
So we just did the assignment?
Mind you, I screwed up. Let me have this.
Did you?
Dude, like addicted to homework, you're a homework junkie.
I wrote all the wrong things in math.
Brandon,
This is hypertonic, hypotonic.
Brandon, you're like a homework junkie.
Okay, is everybody good with that?
Me? Yeah.
Can I answer anything for anyone? Okay, get the heck out of here. You guys are great.